Okay, so yesterday we have completed about interVLAN, right?
Yes.
Okay, so today we have to know a little bit theoretical part before moving towards your other remaining
Okay.
topics of the switch, like
Okay.
IP forwarding architecture. So
Yes.
normally, even if you are talking about Cisco devices, so normally Cisco devices use three type of forwarding architecture. Okay, so what is
Okay.
forwarding? Forwarding or switching is the same thing. See, router do forwarding and switches do switching. So forwarding or switching is the process where the packet is received on the router interface and forwarded out from the another interface, right?
Okay.
But if any router is receiving some kind of information, then after receiving the information inside the router, what router is doing? Okay, which
Okay.
type of process is running inside the router, and after that process router is forwarding the information to the appropriate destination. But how it is working? So normally
Yes.
there are three type of switching mechanism. Forwarding the data is also known as switching, or forwarding the information is also known as switching. So you can see here switching mechanism uh, supported by Cisco. We have three, which is process switching, fast switching, and Cisco express forwarding. So this is the oldest mechanism used by Cisco routers. Okay, but nowadays you will not find this. Okay, it was process switching was used like around like when we were using the iOS version before 12
Yes.
point something. Okay, after 12 point something, then fast switching came, and after 12.4, Cisco Express forwarding came. So process switching is the oldest method, then fast switching came, means better than process switching. Use the concept of cache memory, we will come to know in detail. And nowadays we are using Cisco Express forwarding. Okay. And this is the latest forwarding mechanism in Cisco devices. So
Okay.
if you are talking about process switching or software switching is the same thing. Okay. So you can see here the process switching. Okay, process switching refers to the process by which the router's CPU or processor is directly involved in the forwarding decision. Okay.
Okay.
As the packet is processed, switched through the router, its CPU is responsible for choosing the appropriate process to handle the packet and schedule the running of the process, means how it will be forwarded to the destination. So each and everything will depend on router CPU.
Okay.
Okay, and if your router CPU is not that much strong, okay, so your router can hang, and when your router
Okay.
can hang, your router will restart, and then when your router will restart, your network will down till your router
Yeah.
will come up, right? And
Yes.
this restarting function will be continuous because router
Okay.
will having that traffic every time. Okay,
Yes.
so as normally when you will learn deep about routing and some other things, then at that time you will know more about these structure. So normally
Okay.
this Cisco routers, okay, processor is divided into two part. Okay, one is
Yes.
control plane, and first one is data plane, and then second one is control plane, or you can say
Okay.
it is divided into two part: data plane and control plane. Now what is
Okay.
control plane? Control plane keeps the information about the routing table, means if any packet is coming, then routing table knows that yes, I can forward that data. Okay, so here you can see here, if any incoming packet is coming to router interface, okay, then it will check in the forwarding information base, or you can say forwarding table. When it will not find in the forwarding table, then it will forward to the routing table and asking that, okay, do you know about this in destination? Then router will check its routing table depending on the routing protocol what you have configured, and according to
Yes.
routing table, router will say yes, I know about this information. Okay, and he will send the details that, okay, to reach that destination, this is the next hop router. You send this packet to the next hop router, and that router will forward that packet. And then it will be forwarded to the appropriate outgoing interface, because router can have multiple interfaces, right?
Yes.
Okay, so to reach that destination, maybe your router can use this interface, or maybe this interface, or like fast ethernet 0 by 2 3 4 5. So this is your forwarding mechanism. So in the forwarding mechanism, if any data is coming towards, suppose this is your PC1. PC1 source is 10.1, wanted to communicate to 20.1. So if your PC is forwarding any packet to your router, okay,
Yes.
so once the router will receive the frame, okay, he will check FCS. FCS is known as frame check sequence. This is frame check sequence. So if there is
Yes.
any kind of error in the frame, router will drop the packet. Okay, if there is no error, no problem, then router will check the ethernet frame. Okay, in ethernet frame, that router will check the source and destination information, ip layer, like layer 3 information. Okay.
Yes.
Okay, so once router will come to know layer 3 information, okay, then router will remove layer 2 information, because router do not communicate on behalf of layer 2 communication. Router communicate on the behalf of layer 3 information, right? Because see,
Yes.
when frame is coming, frame will come with everything like source address, like source IP, destination IP, everything. Okay.
Yes.
And when PC is generating, PC has given to switch has given to router, at that time layer 2 information will be there. Okay,
Yes.
so router will say that, okay, I got this information, so let me remove this layer 3, layer 2 information on the from the packet. Okay, once
Okay.
he will have the layer, once he will remove the layer 2 information from the packet, then he will check IP header checksum.
Some.
Means then he will check, okay, do there is any problem on the IP header also, because see, frame header, IP header. Okay,
Okay.
then he will say, okay, after when he will check that, okay, no error, then he will move for TTL value verification. TTL means time to leave. Suppose if I'm coming here to my system, like ping google.com. See, what is TTL value?
Okay.
Okay,
118.
18. So what will happen means, if my packet which I am generating from here, if my packet is reaching to google.com, and okay, right, and if suppose if my packet will not be able to reach google.com, so how it will be working like that? See, suppose this is one router, two router, and this is the Google server. Okay, and now they are connected like this, and you are here. So when you send the ping packet, okay, so it will come first to this router. Okay, so TTL value is 118. Then if this router will forward here, then TTL value will be 117,
Okay.
116, 115, like this. So you have 118 hop to reach there. Okay, this is TTL value.
Okay.
Now if I will come here and I will say ping yahoo.com, TTL value is 45. So TTL value will be
Okay.
different for each and every destination.
So it means that if it's 45 like this, it means that it will go for one server to the 45 one, right?
Yes, yes. 45
So it's
hop. Yes.
hop.
And
Okay.
yes, if I'm pinging to my own gateway 192.168.10.1, is it 10.1 or 1.1? I think it is 1.1. Okay. So normally your system generate 64 is the default.
Okay.
Okay.
Yes.
Okay. Then your router, see, your router hasn't uh, forwarded the data, is just checking the packet. Okay. Then he will check the
Yes.
TTL verification. So if TTL verification is 0, the data will not be forwarded. If TTL verification is 1, data will not be forwarded. 1 means for you. Are you understanding?
Okay. Yes.
Okay. And if TTL value is 2 or more than 2, okay,
Yeah.
2 or more than 2 but less than 255, because 255 is the last hop. Okay.
Okay.
Okay. Then when he will say yes, TTL verification is okay because it is more than 2, then it will look for the destination IP lookup. Okay. And for checking that destination IP lookup, it will check its routing table, right?
Yes.
Okay. So now in the destination IP lookup, if he will check that, okay, whether the destination is connected to me, directly connected, or it is connected to next hop
Okay.
router. Okay, maybe he is looking for this IP, but this IP is, yes, it is in my routing table, but it is connected with my next hop router, and next hop router IP is what? Tell me.
Come again.
See, it will check the destination IP lookup. Okay. So
Yes.
in the destination IP lookup, whether in the frame the destination IP address. Okay. So he will check, your router will check two things. One, whether it is directly connected to me, the network is directly connected to me, or it is
Oh.
connected via any router. Okay.
Okay.
Okay. So here you will check, yes, it is connected via any router, which is my next hop router, and the next hop
Yes.
router IP is 12.1.1.2.
Got two.
Okay. So it will check
Okay.
in,
Okay. Right now you said that the 64 is the default one, right?
yes, yes,
The TTL.
yeah, yeah,
I'm talking about time to live.
yes.
Okay. The default one is 65, but when you try to ping Yahoo, I saw 45.
No, it depends on different destination IP. Okay, see here. Normally, if I am pinging, if you are pinging to your gateway, then it is like that, 1.1. Then it is 64. Okay, pinging to local LAN, then it is 64. Okay, but if I am pinging to facebook.com, okay, see, it is 57. Ping, when you will ping to your local LAN computer, then it is 64. But when you are pinging to
Okay.
any other destination IP address which is not in your network, then it will
Okay.
depending, this TTL is depending on the destination server. So maybe
The
that
this.
destination server has defined that, okay, if someone is trying to ping, right, he, okay, so TTL
Okay.
value for me will be this one. So this TTL value will be defined
Okay.
by the destination servers.
Okay.
Okay. Now, so here what I was saying, that in the frame, in the packet, it will check whether the destination IP address is directly connected to me, or it, I know the
The next hop.
destination address, but it is connected via my neighbor router, and my neighbor router or
Okay.
next hop router is this IP 12.1.1.2, and then
Yes.
that information he will check in his routing table, right?
Yes.
Okay. So in the routing table he will check that, okay, that destination network is means like how, mean how many hop away, like 2 hop away, 3 hop away, or something like that, right?
Yes.
Okay. Or 1 hop away. Then that, then when he will try to forward, so when this router is trying to forward, so this router will not directly forward to this computer, because this router will
No.
forward the information to the next hop router. Okay.
Yes.
Okay. So when he will communicate to the next hop router, then he will collect the information to create new L2 header, because he has removed this
Yes.
L2 header Okay, so he will create the new L2 header with this neighbor router, not with this one.
Okay.
Okay,
Okay.
and then it will modify the TTL IP header checksum. Then it will modify the check TTL. Why? Because from here to here, I
Okay.
told you it was, suppose for example 45, then
Yes.
43, then 42, like that.
Okay.
Okay, then it will create a new L2 header and trailer for the forwarding frame, and then
And
it will
forward
forward the
it.
frame. Okay,
Okay.
because now see, when this packet has reached to this one, right? Okay, so this
Okay.
computer has generated the packet according to his own technology, like OSI reference process, and then when the router
Yes.
receive the frame, then router will reconstruct the packet, and he that router will create the packet according to his own information what he have.
Yes.
Okay, and see, listen this information and this process of the router will be done for each and every packet.
Okay.
Suppose you are there in the network, I am there in the network, and we are communicating to some destination. So router will do the same thing for my packet, same thing for your packet. If I'm generating
Yes.
10 packets, when we ping, so how
Yes.
many packets we have generated, tell me? Normally 4. One packet is always lost, so you just say that 4
Yes.
packets. Okay, send 4.
Yes.
So your
Okay.
router will do this process for 4 times. Okay, in the process switching,
Okay.
same like, like a hub. See,
Yeah.
if I told you that, okay, to reach that destination, okay, first time you can take time, but second time, you can run faster, right?
Yes. Yes. Yeah.
Okay,
This is the reason why for the first time when you ping it will take time, and then the second time.
yeah, this was, no, that is ARP problem, but this was the
Okay.
problem in process switching. Process switching
Okay.
used to do process uh, for each and every packet. It's not that, okay, I can understand that same computer is trying to communicate, okay, trying to communicate, same computer, source is
Yes.
same and destination is same, and if she is sending 4 time packets to the same destination, so it will run the same 4 process for same destinations. Okay, so at that time, your router, okay, utilization was very high.
Yes.
And why at that time router was not crashing or something? Because if you will talk about like before 15 years ago, do you think that we had a lot of people who were using internet or network in his company? No.
It
Even
wasn't.
when I reached to some of the African countries company, okay, at you know
Yes.
the old people were, they started learning computers because the government, I'm telling you, the government said that,
Yeah.
okay, I want to educate my people to learn about computers,
Yeah.
because they were using hard copy, paper, even the police
Yes.
also.
Everything was on paper.
Yes, okay, so I'm saying that at that time people and the network was low, that's why these type of a small routers were able to operate the networks, right? But slowly when the
Yes.
network started, right, when the network increased, okay, at that time the problem came. Okay, now so
Yes.
let's know about some other things to in this. Now remember, all IP address in packet, all sorry, IP address in packets are never changed. Of course, IP address, source and destination IP will never change, right?
Yes.
Yes, but MAC address will be changed after every hop in the packet. Okay, now
Okay.
the type of packet that required software handling include the following. Okay, packet source or destination to the router. Okay, using controlled traffic or routing protocol. So you can say normally when the packet is coming to routers, it use routing protocols to forward the source packet to the destination, right? Now
Yes.
packets that are too complex for the hardware to handle, okay, it used to drop. Okay, now packet that require extra information, okay, that maybe like, maybe some packet do not have information, so at that time router will keep those information on hold and it will run ARP lookup.
Yes.
Okay. Now, software switching is significantly slower than switching done in hardware. Okay.
Okay.
So I remember I told you process switching or software switching. Okay, is the same.
Yes.
Okay.
Same thing. Yeah.
Yes. Packet are hardware switched. Okay. But normally when you are sending some kind of information in your router, right? So it is coming to CPU, right? So CPU is hardware, but inside CPU some information is running, right? Some
Yes,
algorithm
it
is running,
is
so that is software.
software. Yeah.
Yes. Okay. Now, normally if we are talking about IP input, okay, so IP input is related to two things, routing table and ARP table. Okay.
Yes.
Now, obtain the next hop router IP address when any data is coming or any packet is coming to your router. So first of all, if it is related to some specific destination, then your router will look for the next hop router to forward the data, right? To forward the packet.
Yes.
Outgoing interface and the MAC address. Outgoing interface, it will decide, okay, I have to forward the data from this outgoing interface and the MAC address of the next hop router. Okay.
Yes.
Then it will overwrites the destination MAC address of the packet with the next hop router MAC address. Yes, because normally uh, the destination MAC address will be FF, because nobody know about the destination MAC address. They know about source. Uh, source and destination IP address. So in the packet you will find source IP, source MAC, destination IP, and destination MAC will be broadcast, right? FF.
Yes.
Or the destination MAC will be always to the next hop. See, if this PC, let me erase this. Okay, if this PC is sending some information to this destination, right? But
Yes.
in the packet, you will not find destination MAC address with this one. You will find the destination MAC address, the router E0 by
Yes.
0. Okay,
Okay.
I will show you when we'll do the practical.
Okay.
Where's that? Okay, now it will overwrite the source MAC address with the MAC address of the outgoing. Yes, of course. Yes, we have seen. It will decrement. Okay, decrement the
Okay.
TTL value. Okay,
Okay.
and it will recompute the IP header checksum. It will check every time that whether the IP header checksum does have some error or not. Okay, and then it will finally deliver the packet to the next hop router. Okay, so normally see
Okay.
how the process switching works. See, when any layer 3 layer 2 frame combination, right, it will come to
Yes.
the router.
The
Okay,
interface. Yeah.
yes, then this is known as ingress interface. Okay, okay, ingress means
Okay.
incoming, and egress means outgoing, or you can say input interface and output interface. Then
Output.
when the
Okay.
data will come here, okay, then it will interrupt here, means stop the processing, and then it will
Okay.
forward to the router
So,
routing table to find the information. And when the router will find the information, okay, okay, and the information is finding by the software according to the
so
algorithm. Okay,
okay.
and then when it will find those information, then it will forward through the output interface.
Output.
Simple.
Okay.
Okay, now see, and the problem in the process switching was that your process switching or your router do the same function for each and every packet. So for that your router CPU utilization was very high. Okay, now we have to move to the fast switching, and now you will see that how fast switching is working. See,
Okay.
in the fast switching, routed once, forwarded many times, means In the process switching, for every packet it will look for routing, for every packet it will look for processing. Okay,
Okay.
but in fast switching, okay, can you give me one? Okay, now in second IP forwarding mechanism, which is fast switching. So I told you in the fast switching we have the method is routed one and forwarded many times, means it will use some kind of storing mechanism. So what he is using, see, remember I told you in the fast switching we use cache memory, right? Okay,
Yes.
so for the first time each packet is process switch, same, it will run like a process switching, but for the next time forwarding of the packet to the same destination, okay,
Yeah.
uh, with the help of means it will be forwarded with the help of previous information which is stored in the cache memory.
Push memory.
Yes, now, but cache memory storing has also some kind of limitation, right? Okay,
Yes.
now let's understand about some drawbacks of this fast switching. So the first drawback is this memory contains the information of every destination IP address. Means if this computer, if suppose this computer is trying to communicate to this computer, right? So this is source IP, this is destination IP, right?
Yes.
Okay. Again, if any source IP will come like 10.2, 10.2, 10.3, 10.4, 10.5. So for each source and for each destination IP, not network, your
Yes.
your router will create cache memory and it will store there. Now tell me,
Okay.
your router routing table is constructed as per network or as per IP?
As for IP.
No, no. Routing table is what? It store IP or it store networks?
Network.
In network, yes. So do
Mm.
you think that if router will start storing, okay, it will start storing some kind of information like related to IP. So maybe it can have thousands of IP addresses stored on the router. That's why in the router you will only see what network. Okay. So here it's saying in the fast switching that it will store the information in your cache memory related to each and every destination IP address. Okay. It will not store the destination route. Okay, it will store the related to the information on upon the destination host. Okay, so this was the first, and due to this problem it will consume lots of cache memory. Okay, so this was the first drawbacks of fast switching. Now the second drawback of this fast switching is, now every time layer 2 entry is changed, means if PC1 was removed and PC2 was used its place, means on its place, so this new PC will have a new MAC address. So instead of just updating the layer 2 entry in the forwarding table, it will delete all the old entry and it will create the new entry with the help of again process switch. Now see what is the problem. Now for example, suppose, sometime in the organization, sometime maybe right now you'll see PC1 is connected here, right? Okay, and maybe some, you remove this PC1 and you connected PC2 here. Okay, so source is different but the destination is same. So according to you, right, you will say that okay, no problem, if the source is different I will only change the source information because other things are same. But in the fast switching, what they're doing, they are not changing, they're not updating the old entry, they are deleting the old entry, and they are constructing the new entry with the help of process switch. So again, your fast switching is what? Process switching. Now again, third drawback, the again second time, the again time of entries of the forwarding table will be the aging time of the entire entries of your forwarding table will be slow. Why? Because every time he's changing up, see, there is no update. Okay, so when they are running the process switch, so again that fast switching is same like a process switch, which means the old entry will keep on deleting from the forwarding table, and the new entries will be keep on adding. Okay, so again, instead of fast switching, again you are running with the process switching. So you can say your router is working half as a process switch and half time as a fast switch. So this implementation was not successful. Okay, that's why they came with another routing mechanism or switching mechanism that was known as Cisco Express Forwarding. Now, number 4, balancing can be only on per destination basis. Okay, means load balancing was not configured or not be supported with this fast switching. It was supported, but as per destination basis, not as per what you can say, not with the network basis. Okay, now we cannot do per packet load balancing. Okay, means suppose if this is a PC, if this PC is sending some information here, so I want to do some kind of load balancing. Okay, so the one packet will come here, then second packet will come here, right? So for load balancing, see, source information is same, but the destination information is changing, right? But this was not supported. Why? Because when your router was constructing the table, okay, so at that time in the cache memory, so router was making for in the cache memory, router was storing the information about this destination. Then it, when the new information was coming, so it was deleting for this one, then keeping this one. So that's why saying that keep on adding and deleting. You can see here, keep on deleting and keep on adding the new. So that's why load balancing was not supported in this one. Okay, now after 12.2, or you can say 12.4, okay, Cisco came with Cisco Express forwarding mechanism or technology in the process, or you can say in the switching mechanism. Then your switching is faster as compared to process switching and fast switching. So here see what how this fast switching was working. Same, this packet was coming to your interface, stop in the queue, then it will go for first process switching. Okay, and for process switching it will check in the routing table. Yes, the information is there. Then it will create the cache memory, means it will keep the information in the cache memory, and then it will forward the information to the outbound interface. Okay, or outgoing interface. Now there are some technology which was used in your fast switching. So there are two type of, see, these all switching mechanism what we are going to learn, it is related to high end devices. Okay, because see, when we will learn about CCNP, so you have to work on high end devices like distribution switch or distribution routers, or core layer switches, or maybe core layer routers. So in that condition you have to understand about processing information, because how many data your router is receiving or packets receiving. So you must know that okay, this router cannot process that much of packets. Okay, Now, so whenever forwarding mechanism you are talking, so there are two type of forwarding mechanism. One is centralized and second one is distributed forwarding. Centralized means when both rib and fib, rib means routing information, okay, or you can say routing table. Fib means forwarding table, means this one, routing table, and this one in this forwarding table, this one, okay. When the router is forwarding, remember I told you router is divided into two. One is data plane, okay, and second one is forwarding, okay. Let me show you again. See, sorry, data plane and control plane. So control plane is your routing, okay, and forwarding information base, or means forwarding table, will be created in the data plane, okay. So when both sorry, where both rib means routing in table and forwarding table are handled by the same router, okay, or routing process or router process, okay, it means all of the switching destination decisions are made by the single processor, okay. Okay, so now here,
Okay.
you know that in our computer you have heard that dual core to dual, and 8 core, something like that. In our laptop processor or desktop processor, dual core,
Yes.
yes. So you know the device like Cisco, when Cisco also thought that, okay, instead of having a single processor, we can have multiple processor also in our router, right?
Oh, yes.
Because single
Yes.
processor is having problem, okay. So same you have, so let me show you something like that. Why that CPU is not see, okay. So can you read here, 18 core,
It's for beast.
okay.
Okay.
So these are a single processor, but inside that single processor you will find multiple cores, means multiple small processors, okay.
Okay.
So Cisco also thought that, okay, instead of having single processor, we can have multiple processor inside single processor. That's why dual core to duo, and 4 core, 8 core processor started coming, and then we came with the new technology like Core i5, Core i3, like that. Okay,
Okay.
now,
Yes.
so this was the centralized, means everything will be done by single processor, that is centralized. Centralized means what? Everything will be done by single man, that is centralized, right?
Yeah,
But
focus on the same only one.
yes, but when you are talking about distributed, distributed is saying that when any data of packet will come, okay, so it will come to your line card, means your NIC card, and what they said, your NIC card will having one CPU, okay. So if you see
Okay.
here, okay, so some NIC card which was used in the router, they started coming with separate processing unit, okay.
Okay.
So when the data will come, okay, so your NIC used to keep information or store the information related to the,
And I
see, related to the forwarding you know
process.
those things, the cache memory and all those things.
Yeah,
Okay.
those are the cache
Yes.
memory.
So those processing informations will be handled by each and
Cache
every
memory.
interface.
Okay.
Okay. So in the distributed, what is saying that whenever, maybe if I have four interface, so my all four interface will have four CPU, and all those four interface will do those processing separately.
Okay, they'll
Okay.
share it
So each and every interface will be managing routing table and
for
forwarding table. Okay.
yes.
Means, it means there will be separate processor for routing information base and forwarding information.
Okay.
Now, disadvantage of centralized, you know that disadvantage, that yes, disadvantage means for handling multiple packets, which, okay, maybe your router
Will
will take
crash.
time, right? In the centralized.
Okay.
But when it is distributed, in that condition, distributed means when the data is coming, it is forwarding with
Yes.
the help of separate table, right?
Yes.
Now, but you said that okay, distribution is okay, distribution kind of technology is okay, but how many interface you can have? You can have maybe like four interface, five interface, or eight, six interface on the router, or maybe eight interface, right? But that interface storing or creating separate table or process will have some limitations, right?
Yes.
Okay. So finally they came with CEF, Cisco Express Forwarding.
CF. Okay.
So what CF is doing, CF is very clever as compared to your process switching and fast switching.
Fast switching.
CF is doing same like like artificial intelligence. What CF is doing, whenever you will create this like routing information, if this PC wants to communicate to suppose this destination, okay,
Okay.
so each and every routing information will be on this router. Okay. So whenever you are forwarding, you are trying to forward this information, okay, to, towards this router, right? Okay,
Okay.
to this specific destination. So first time your router will create your routing table, right? So
Okay.
each and every
Yes.
information is there in the routing table. So what CF will do, CF is a Cisco Express forwarding process. What it will do, CF will copy those information.
Okay.
Same the routing table, CF will copy the routing table, okay, from CPU, okay,
Okay.
and it will keep here as a cache memory, okay.
Okay.
And when he will say that now CF is saying that if you want to go, okay, you can come to me, okay, and I know where to forward, okay,
Okay.
and I have copied those information, and who gave me this information, this routing table. So router has done
Yes.
first time process, and now router is silent now.
Okay.
So any information is coming to CF. CS is saying that okay, you want to go to that destination network, not destination IP. Okay,
Okay.
and then it will saying that okay, I know about that destination network. But initially, your in the process switching and in the fast switching, your router was maintaining the destination IP information. But now your CEF is saying that okay, no problem, it is same carbon copy of your routing table. It is saying that okay, if you want to go to that destination network, no problem, I know who is the next hop. Okay, he will send here, this router will send here, and you will be able to communicate simply.
Okay. But the CF is inside routers, right?
Yes, yes, it is inside the
Okay.
router. Okay.
Okay.
Okay, no problem, let me show you. Okay, so if you'll type here so IPCEF, okay, it will tell you. See, so IP route. See, so IP route. Okay, in the so IP route you have the information of these networks, right? Okay,
Yes.
in the so IPCEF is information on the same. It is, you can say, and it knows that okay, if I want to forward this information, okay, see, it is attached, means
Yes.
okay. Now next hop, you can see here next hop information, okay, which is attached. Okay, if any IP is coming related to this, what I have to do?
Okay. So it's like a schedule of everything.
Yes. Okay, so CF is used in the new technologies router. Okay, new routers. So in this forwarding mechanism, when router received a packet for a particular destination, it never does the routing table lookup. The reason is CF does not need to receive packet to start any kind of forwarding process, because it, okay, there is no process. It just copy the information, and whoever wants to go, just come, okay, and take the information and go to the destination simply.
Okay.
Now, same like unlike the you can say other previous forwarding mechanism, where
Yes.
forwarding lookup starts only
Only.
after you receive some packet to be forwarded, right?
Yes.
Okay, and then it lookups start. But here the CF is already there. If you are coming, take the information and go. No, it's not that when you will come at that time I will look for CEF.
Okay.
Okay. So when you have configured any kind of routing in the router, either with the help of static routing or dynamic routing, and routing table is created after that. So what CF does, it creates its own table along with the routing table. It's like same like a routing table with routing table. We can say that CF is not depending on the routing
Routing
table
table.
for forwarding the packets. Okay, so
Okay.
if any data is coming, so it will come to CF and CF will forward. No need of routing.
Okay. Cause he has already copied everything.
Yes, yes. It has
Okay.
own way of forwarding. Okay, and it creates two type of forwarding table.
Forwarding.
Same forwarding information base and adjacency information. Adjacency means this one. This next of information. Okay, this is the forwarding. Prefix is known as forwarding, to where I have to forward and to where I can reach. And next hop is my adjacency detail, means my neighbor details. Okay, now first CF creates the database for all the routes prefix or destination network is the same thing, that are reachable. Then it creates the
Okay.
separate database where it stored which destination can be reached by which adjacent router. Adjacent router means neighbor router. So see here, prefix,
Yes.
I can reach here, I can reach here, and this is connected. I can reach
Okay.
via this next hop router. This next hop router
Okay.
means my router 2. This is router 2 IP address. Okay,
Okay.
this is forwarding information base. In the adjacency, what I told you, I can reach this network, and this is my neighbor IP.
Hop. Yep.
Now, pre-constructed layer 2 information is in the adjacency table. So in the adjacency table you will find some kind of details related to MAC. Okay, this is my
Okay.
next hop IP address, this is the forward exit interface, and this is the MAC address of the neighbor. Okay,
Okay.
so here you cannot see, but if you are using layer 3 switch, you can find this information. Okay,
Okay.
so no problem. We have layer 3 switch? Let's try console. Okay, it's not there, no problem. Yes, inter VLAN. Okay, see here. So your switch also maintain the CEF table. Okay, your router, your switch.
Okay. Even the switch here.
Yes.
Okay.
Okay. So the next hop address in the forwarding table will be known as a pointer. Pointer is known as my neighbor. Okay, means if any information is coming towards that specific destination, and that destination will be known by your neighbor, so that is known as pointers. Okay,
Okay.
and there can be a single pointer for multiple destination. Of course, single point, maybe I am only reachable to ISP, and ISP is reachable to multiple destinations. Okay,
Okay.
okay, so this is the major benefit of CEF, that you do not need to create any kind of extra table,
Okay.
and you not means your router do not need to create any kind of extra table, and that table is just a copy of your routing table, and it is
Okay.
permanent. When it will, means it is in the RAM. Okay, it is not stored
Mm-hmm.
somewhere, only routing table is stored in your NVRAM, but your CF
Okay.
is always stored in the RAM. Okay, so whenever your
Okay.
router starts, your CF will be automatically copied to RAM, and then your RAM will start working.
Okay.
So you know that RAM is faster than CPU, or CPU is faster than RAM.
RAM is faster than CPU.
Yeah, gig RAM is faster. That's why the running condition. See, right now we are working, we are chatting, videos are running. So everything is running on
Yes.
RAM, not in our
RAM.
not
Yes. I
yeah.
can
See,
remember last time that you told me that I should increase my RAM
yes,
so that.
okay.
Okay. I see.
So this is all about your few things about
See here.
FIB. Okay.
See here.
So TTL value will be, which thing can be modified in the CF. Your TTL value will be modified, of course. Okay, and
Okay.
IP checksum will be modified or checked depending on the source and destination. Okay,
Okay.
now the IP checksum, you will find in only IPv4, not in IPv6. Okay,
Okay.
okay. So CF is same, like there are two type of CF. One is hardware CF, and second one is software CF. Okay,
Okay.
so hardware CF need separate line card, same like separate interface card. But right now what we are
Okay.
using in our router, that is software CF what we are using.
So,
Okay,
okay.
so same here, you see the packet is came here to the interface, then it came to this, and then first it will go to CF switch, and then it will come here to the table. It will say there is no
Okay.
entry, then it will come here. Okay, and then it will drop. But if there will be entry, okay, okay, and entry has been copied from here. See here, you can see here, entry has been copied from
Okay.
routing table, and if there is entry, it will come here and it will forward the, and
Got
it will
it.
forward it to the
Okay.
destination. Okay,
Okay.
and this process is
So
single
if there is
timeless.
another router here, if there is another router here,
Yes,
it's gonna do the same and
yes,
forward it
same,
to
same, same.
the next one.
Yes,
Okay.
and if routing table will be updated, then your CEF table will be updated.
Okay.
Okay, and if your routing table is constant, means your CEF table is also constant.
Anyway, he used to copy
Yes,
everything that he's.
yes. Software CF will be using your CPU. Okay, and
Okay.
hardware CF is using your single. For each card, there will be separate process.
Okay.
Okay, but yes, you will find some hardware CF in the core layer switch. Okay, core layer switch. I
Okay.
can show you here. See, this is, we cannot configure this. Okay, this
Okay. It's
what we
something
are
that's
talking.
okay.
Yes, but we should know. You know
Okay.
about OSI reference model, right? Do you think that we
Yes.
should
Yes.
do something with the OSI reference model? But we should know.
Not, yeah.
See, these are core
Especially
layers.
the
Yes, these are core
fourth one.
layer devices. Okay, see how big these. Okay, so these are very, catalyst. When you learn about some stacking or something like that, in that
Okay.
time you will understand about these processing.
As for the OZ, it's just maybe it can help us just to troubleshoot. That's all.
Yes, yes,
The first four.
yes. Which one? Hello.
Yeah, I'm listening.
Okay. So now, okay. So this we have already came to know that as part of packet forwarding process, the packet header are always rewritten.
Everything.
Okay. Now
Yes.
the router overwrites the destination MAC address of the packet when with the next hop router MAC address. Okay, from the adjacency table, and of course there is adjacency table and CF table. It means CF table is divided into two. One is
Okay.
FIB and AIB. Means FIB means forwarding, means forwarding table,
Forward.
and adjacency table. Okay, you can see here
Okay.
there is two table. Okay, forwarding table and adjacency table. Okay, adjacency means my neighbor information, and forwarding means where to, means the network information where I can reach or where I can forward the data of packets. I told you it will always decrement the TTL field. Okay, checksum will be checked every time. Okay, and finally it will deliver the packet to the next hop router. Now note, the packet processed by CPU are typically subject to,
I
like
I
rate
lost you.
hello.
I lost you.
Okay,
Yeah, I lost you about 20 seconds.
okay. Now we talk about this one. Okay, I
Okay.
said this as a part of packet forwarding process. Okay,
Okay.
the packet header are rewritten, and in this it's the same technology what we have understood in our fast switching or process switching. Same thing. When
Okay.
the packet will
Okay.
come to the router, it will overwrites the destination MAC address. Okay, and it will change the destination MAC address as per the next hop router MAC address, and those
Okay.
next hop router MAC address and the information will be stored in the adjacency table. So normally CEF create two type of table: forwarding table and adjacency table. Forwarding table is will have the information about the destination networks or destination prefix, and adjacency table will have the information about the neighbor
Next
routers.
up.
Okay, same of course it will decrease the TTL value. It will check the IP header checksum, and then it will forwards the data to the final destination. Okay, and here are some kind of important, like if you are talking about packet processed by the CPU are typically subject to a rate limiter. Okay, and
Okay.
when an like invalid or incomplete adjacency exists, okay, to prevent this starving of CPU cycle. Okay, so what is saying that router or your this, what you can say, like suppose if you have kept some kind of information in your routing table. Okay, so some routing table, like I hope you do, about that EIGRP. Do you know about EIGRP? mm, I forget that one. What is the name of that? One second.
Okay.
Okay, so in EIGRP, you will find some kind of, that problem, stuck in active problem. So
Okay.
the network is down, right? But
Yes.
your EIGRP will keep the information about that routing table for 3 minutes, right?
Yes.
And your CF will copy that information, and when any information will come towards that destination, your CF will forward, right?
Okay.
Okay. Now same thing, your RIP will keep the information for 3 minutes, and then it will flush out, then again your CF will copy those informations, right?
Okay.
Okay. To stop these kinds of problems, right? Okay.
Yes.
They came with some new technology to stop loops. Okay.
Okay.
Now the TTL is the layer 3 loop prevention mechanism that reduce the packet TTL filled by 1. Remember I told you, if it is 0 it will discard, if it is 1 it will
Yeah.
discard, but if it
This
is higher
better
than 2, okay,
than 2 years.
and less than 256, okay,
Okay.
then it will be forwarded. Okay. So when any
Okay.
data is coming towards that destination, so it will, when it will see that okay it is there in the routing table, right? But once the destination is not reachable, okay, it will not accept that TTL towards that network. Okay. So this is little bit more, technical, when you will see and when you will read the packet with the help of what you can say.
I lost you again.
I'm saying that
Yeah.
when those problems related to stock inactive kind of problems comes towards your CF, right? So your CF always use this TTL kind of prevention mechanism. Simple, that is. Okay. Okay. Now that was related to your hardware software CF. Now if I'm talking about hardware CF, so hardware CF is
Okay.
divided into two part. One is application specific integrated chip, and second one is network processing unit. Means that the hardware CF what we are talking means for individual interface there will be CPU. Okay.
Okay.
Okay. So you will have two type of CPU inside your that LAN card. Okay.
Okay.
So those things works on processing individually. So here also I have just information about this one, but I do
Okay.
not have deep information because this is related to,
Okay.
totally hardware. Okay.
Okay.
So here what I am just putting you in knowledge that these type of processing in, see, it's not that we know only about routing and we just went to the company and we started routing. But when any
Yes.
problem will come, then how you will know that okay, what this problem is related to my routing, or this problem is related to the network, or this problem is related to the hardware what I am using.
Yes.
So how you will explain to your boss? So you should know that okay, this
Yes.
type of problem is there, your router is hanging, your router is slow. Okay, so why your router is slow, whether you are using which type of processing. Okay.
Yes.
So same here, like how we can enable CF. So you can enable CF as per interface basis. Okay, if you are using
Okay.
a distributed CF. Okay, distributed CF means multiple means
Okay.
like multiple
How
interface
do I
with
run?
multiple processors. Okay.
Okay.
Or you, if you want, you can enable, if you want to enable globally, so you just go there and type IPCF on global mode, it will be enabled. Okay.
Okay. Okay.
If it is not there. Okay, but if it is there,
Cool.
you can check. Okay.
To make sure whether it's there or not. That's all.
Yes, so if you want to check here, so adjacency,
Sure.
see, right now maybe this is a single switch, but if you will see here, maybe if I have some routers, Okay, let's take this one. Maybe if I have some. Here I do not have routing, but we will run one routing. So if I'm coming on router 1,
Okay.
so IP route, no routing. So what I will do here, I'm just running conf t router rip version 2 network 0 no auto.
Okay.
So CEF, so IPCEF, and then so adjacency, no adjacency. But if I'm coming here, router rip version 2 network no auto. Okay, now if I'm coming here, so IP route, yes, you have 20 information. Then so IPCEF, see here, you have 20 information. And see, this is the next hop router information, right?
Yes.
Okay, and then if you're typing here, so adjacency, see, you will have this. Okay,
Yes.
and means your neighbor detail. So
Yeah,
this,
the address of
yes,
agency.
so your CF is already working. And if you're checking here, so version, so I'm using the latest one, of course. But if you use the lowest one, even after 12.4, you will find CF.
Okay.
Okay, so you can check
Okay.
that whether your router is supporting CF or not. And if we are talking about MPLS, so those devices who do not support CEF, okay, on those devices you cannot run MPLS. So for running MPLS,
Okay.
CEF must
You
be
do
there,
have. Okay. I see.
because MPLS forwards the data on the behalf of CEF.
Okay.
Okay, so now this we have already know about what is cam table, right? Okay,
Yes.
now see, there is other memory which is CF is also stored somewhere, right?
Okay.
Okay, so that is known as TCAM. Okay, ternary,
Okay.
yeah, ternary content addressable memory.
Yes.
Okay, and there are some kind of other memory which is known as stateful switchover. Okay, and stateful switchover memories are used for high availability kind of, okay, when you want redundancy kind of thing. So here we are talking about router memory. Okay, how forwarding, so
Okay.
see, forwarding decision, routing table is also stored somewhere. Okay, forwarding table is also stored somewhere. Okay, so these all informations are stored somewhere, but these all are memory. Okay, this stored stateful is done for this use. Okay, this, what you can say, tcam is used for different thing, cam is used for different thing. You can come here, sdm is also there, switching database manager. Okay, so this all database what we are talking, see,
Okay.
route, even I'm talking about, see here, your system has a single hard drive, right?
Yes.
Okay, but you have divided. Okay, this drive is for this drive, this is for this is for this, you have divided, right? Okay,
Yes.
so same here, in your router you have a single memory, single database. In that database, your database has been divided into multiple sections. Okay,
Yeah.
means,
According to you.
yeah, this is used for this information, this table is used for this information, this table is used for
Yes.
this information. So this is maintained by switching database manager. So if you are coming here and typing one command here, so SDM PE prefer. Maybe it will show. Okay, no problem. Okay, packet tracer. So let me use high end 2811 one router and one layer 360. This one. Okay, these things you find in the high end devices.
Okay.
So if I'm coming here, enable, so SDM prefer. Okay, not there. Now come here. Let's see. I have to power on first. Zoom in.
Yes.
Where is power on? AC power supply. Okay, is it there? CLI. Okay. No. And also SDM. Okay, see here. So you can see here it has memory, right? So in that
Yes.
single memory, okay, see, you can see here the unicast MAC address, how much I can store? 8,000.
Yes. Yes.
Okay, the access list, how much access list I can use? Okay, like around
Yes.
250 access list I can store here.
Yes.
Okay, uh, some multicast information. Okay, routing table means 2050 routing tables I can store. So these informations are there, means, see, you have a single memory. Okay,
Yes.
single memory, and your single memory is divided to store multiple informations, right?
Yep.
Okay, so it doesn't mean that, see, it is not like your computer that you came here. Okay, you have C drive, you did partition by your own, right? You said, okay,
Yes.
I want to use this much here, so you partitioned the disk according to your need. Okay, so you said, okay,
Yes.
I want to store movie around 200 GB, but I want to store my data only 50 GB, right? But this is not in your memory is there, and it is divided according to um, use of your switch and router, that okay, the quality of service information will be stored like this much. Okay,
Yes.
your access list can be stored here this much. Okay, so this is your memory allocation information, you can say. Okay,
Okay.
so why we are knowing, suppose you are working as an engineer, right? And see, the CCNP is not like CCNA. So when you are trying to store, and after some time your router or your switch is not accepting those information, then how you will know that, okay, why they are not accepting? Are you understanding?
Yes.
So you should know that, okay,
Okay.
this router cannot store this much of information. Okay, and then you will check. Okay, so IP access list, and then you will say, okay, access list is stored, or see, this about this router or this switch
Okay.
is saying that it will store only 375, but if you try to create more access list, okay,
To not accept.
it will not accept. Then how you will know why it is not accepting? Because see, in your company, your devices, maybe you will use this device like 5, you will have another device like 4. So each and every device capacity will be different, right?
Yes.
Okay, So this is related to switch device manager, means it's a memory allocation information. Okay. So see,
Okay.
today what we have learned about switch and router forwarding mechanism. Okay. So
Yes.
switch and router forwarding mechanism is divided into three part. Okay. Process
Yes.
switching, fast switching, and Cisco Express forwarding. Okay, so we have
Expressive.
understood why we are not using process switching, why we are not using fast switching. Nowadays we are using CEF.
CF.
Okay, and why we are using CEF, because CEF create a separate table. Okay,
Yes.
to forward these source and destination information towards
Yes.
the specific network. Okay,
Okay.
then we came to know about memory, that okay, we have CAM table, we have MAC table. Okay, we have TCAM table. Okay, we have routing table. But how many, so we have single memory, but we have multiple
Yes.
type of information, but who is managing those multiple type of information? SDM. Okay, and SDM has divided that, okay, you can store this much of information in this. Okay, this much, so it divided. Okay,
Okay.
so this is all about that SDM. And now tomorrow we'll come to know about VTP and ether channel. Okay.
VTP. Okay. VTP. The channel.
Yes.
Cool.